All right, so what we're going to do today, the first part is something that we have done already, just a refresh of your memory about functions. And then we're going to do something specifically about functions. Like the main goal is going to be to figure this, which is called difference quotients, which is going to be very, very important in calculus, but we're going to review the functions first. So remember, a function is a rule that assigns the input exactly once to the output. So we talked about functions already more than once. And recall that y and f of x are exactly the same thing, okay? So what's the advantage of having using function notation, which is one of the things we have already done, but what is the advantage is this, look. Before, if you have, for example, y equals to 7x, okay? You have y 7x. If I want you to do something with this, I had to specifically explain what I mean. I will tell you find y when x equals to, for example, 2, okay? And then what do? You say, well, y is equals to 7, you plug in the value for 2, and you get 14, which is, there is nothing wrong with this, but that's what we have done before, okay? So what's the advantage of this notation is that instead of saying find y when x is 2, all you had to do is write this. You say f of 2. So this is equivalent to this. So instead of saying just all of this, then, so let me change the color, then you just do this. So f of 2 is equivalent to saying find the value of y when x is 2. And actually you need to know that that's what it means. That's the whole point, okay? So that makes life easier. And then the answer is going to be the same. It's still going to be 7 times 2, and then this is 14, okay? All right, so let's start by evaluating these functions. So this means what is the value of y when x is 2, or just plug in 2. This one is minus 1, a and a plus 2. So let's start with this one. So just plug in 2. So this will be 2 squared, 2 times 2 minus 3. Now notice that 2 squared is 4. So this will give you 4 plus 4 minus 3. And this will be a minus 3, which is 5. Okay, so that's all it means. So when x is 2, y is 5. So something else that you need to make the connection, and remember that if, okay, so know this, and this is applied to any functions. No, if f of 2 is equals to 5, that means this is the point 2 and 5. So this is the same thing as saying the x is 2 and y is 5. So it's important that you make that connection between the two, because that's what it means. All right? What about f of negative 1? This will be negative 1 squared plus 2 times negative 1. And then just make sure you follow the order operations. Minus 1 squared is 1. 2 times minus 1 is minus 2. This is minus 3. And then 1 minus 2 minus 3, well, the whole thing will be negative 4. Now remember what this means. If x is minus 1, y is minus 4. Okay, so that's important that you make that connection. What about f of a? So this one you plug it in, and this will give you a squared plus 2a minus 3. Since you don't know what a is, that's as far as you can go for now. That's it. That's the answer. So for example, if I would ask you how much is f of, let's say, r, what do you think the answer will be? It will just be r squared plus 2r minus 3, because you don't know what r is. Okay? All right, now, this one, pay particular attention to this, because we're going to need this in a little bit. The main thing right now is notice that if whatever is here, replaces the value for x, okay? So whatever is here is gonna replace the x. That's the thing you need to understand, okay? So now this one, actually, let me rewrite it. It's the same thing, but it's easier to see it this way, a plus 2. So we plug it into the formula. This will give you a plus 2 squared plus 2a plus 2 minus 3. Okay. Now notice that in this part, for this one, you can use the distributive property. You cannot distribute in this one, at least not the way I did the other one. You had to do what in high school they call a FOIL, but it's technically the distributive property, okay? So it's very important to remember this. Look, note, this is a very common mistake people do all the time. A plus 2 squared is not a squared plus 4. That's the most common mistake people do. Actually, a plus 2 squared means a plus 2 times what? What do you think? A plus 2. And then if you distribute, this will give you a squared plus 2a plus 2a plus 4. You probably did this in high school like 500 times. So this is one of the few things that they actually do there a lot. And if you combine like terms, this is equals to a squared plus 4a plus 4. Okay? So therefore, this part, this is going to give you a squared plus 4a plus 4. And this one, if you distribute, is going to give you 2a plus 4. And then you have a minus 3. And then just combine the like terms. So you have a squared, 4a plus 2a, that will give you 6a. And then 4 minus 3 plus 4, that will give you 5. And that's the answer. Okay, so the difference between this example and the previous one is that this one is a piecewise function and the other one was just a regular function, okay? So here, you have to be sure you are in the correct value for x before you plug it in. So for example, this one says x is negative 4. So what's the value if x is negative 4? Well, negative 4, it will be in this case. Why? Because negative 4 is less than negative 3. So therefore, the answer is going to be x. Well, what's the value for x? If you plug in x, this will give you just negative 4. Okay? What about f of phi? Well, phi is right at the end, but it's still part of this. So you have to use this equation. So this will give you 2. Instead of x, you're going to put phi plus phi. So this is going to give you 10 plus 5, which will give you 15. So again, remember this means this is the point 5, 15. Well, this one, this is the point negative 4 for this case. Well, what about f of 10? 10 is bigger than 5, which is right here. So any number bigger than 5 is always going to give you negative 4. So the answer is just negative 4. That's it. Well, let's see. Let's add one more. What do you think f of 0 will be? Well, 0 is between these two. So you're going to have to use this formula. So it's going to be 2 times 0 plus 5, which is just 5. And that's it. Okay, so now let's evaluate the functions graphically. So this is what I mean. Look, notice, like I mentioned, that if you were going to graph this, let's say that we didn't do this question at all, like we didn't do this at all, and we just focus on this. This was a question. This is exactly the previous function, okay? Now in graphical form. So here, no, this goes from minus 3 to 5, more than 5, and less than equals to 3, okay? So if you have this graph, and I ask you how much is, let's call this A, how much is f of, like, I don't know, 5. Okay. So you come to 5. This goes all the way to 15. So the answer is 15. And that's it. If I ask you how much is f of negative 6, negative 6 is right here, right? It goes down to this value, which is also what? Negative 6. So you can see that how it's pretty straightforward. Okay? If you do like f of 4, that one is a little more tricky, but let's see. Let's say you have f of 4. 4 is right here. It goes down to here. So what value do you think that is? 13. The only disadvantage of the graph is if everything is not labeled correctly, then it will be tricky because now you have to approximate the answer. For example, here, look, the 2 is not here, right? So if I ask you f of 2, you will have to say, well, f of 2 is 9, which it is, because remember the function was 2x plus 5. So 2 times 2 is 4 plus 5 is 9. So f of 2 will be that. But if I ask you f of 3, it's somewhere here, which is 11. But it's not clearly labeled on the other side, so it may be a little more tricky. But you can see how you have a graph to get a function, to get the values is very, very easy, okay? So just remember that every time you have a question and they ask you to read the graph, that's one of the easiest questions you have on the test, because all you have to do is look for x and find y. That's it. All right, so all you have to do is look to the graph, find the values. The easiest way to do these things is the following. Look, remember that this represents the x value, and this is asking you what is the value of y when x is 0. So all you have to do is go to 0 first. X equals to 0 here. This goes up to the number what? 1. So the answer is 1. By the way, so you should know this because you're gonna need this later too. F of 0 is always the y-intercept. So if I ask you to find the y-intercept, it's the same thing as finding y of 0. So in this case, this is 0, 1. So that's the y-intercept. Now, what about f of 4? What will be the value for f of 4? 2. So it's 2. 4 is right here. Goes the way there is 2. What about f of minus 2? 5. And what about f of 2? Is no solution, or it does not exist because there is a hole in there. So 2 is here and there is nothing there, so there's no solution. That's it. Is that okay? Any questions on this? Now, just pay attention to this part before we go to the next one. This is like a backwards problem. So this is going a little backwards. This is what I mean. Look, if I say this, look, E, special letter E. If I tell you for which value of x is the answer equals to 0. So what will that be? So now I'm telling you y is 0. What's the value of x that gives you that? It will be 3, right? Because the actually is 2. This one, 3, and negative 4. Let's say now even it's 4 point something. So x is equals to 3, which is right here. And this one, let's say, is negative 4.2 or something like that. Okay. And these are called the x-intercepts. Okay, far so good. You have 2 points, right? You have a point here, another point there, anywhere. And then, for lack of a better name, we're gonna call this one x1, and this one obviously what? x2. And this will be y1, and this will be y2. Okay. And then you will create usually this is the line that you want, the slope, and usually you do a triangle like this, and this is it's called the rise, right? And this usually is called the run. The point is that the formula for the slope was what? y2 minus y1, which is rise over run. So that's not new. You've seen that many times, okay? So what we're going to do now is change the notation slightly, and you'll see why is needed. So remember that what's another name for y2? y2 is the same thing as what? F of x2. And y1 is the same thing as f of x1. Okay, so remember that, that's important. Okay, so therefore, to make things more annoying, so I'm gonna call this one A, and this one B for now. So instead of x1 and x2 is A and B. So therefore, this is going to be f of what? B, and this one is gonna be what? F of A. Works good? So then the formula for the slope, we're gonna rewrite it as f of b minus f of a over b minus a. Now, just for the record, you can also write f of a minus f of b, but then you have to do a minus b. These have to match the letters there, okay? All right, so now clearly, that's the formula for the slope. If you use the whole formula, instead of calling it a slope, it's gonna be called now, the whole thing is called average rate of change. So average rate of change and the slope are exactly the same thing. And then to make things a little more complicated, but they shouldn't be, just the top, this part right here, is gonna be called the net change. So the net change is just the y2 minus y1. So that's just the notation. So if I ask you to find what is the net change, it's just asking you this part, look. F of b minus f of a. This is the net change, while the rate of change is just the slope. Is that clear? All right, so you have this function, f of x equals to x squared, and it says find the net change. Remember, that means just y2 minus y1. Or f of b minus f of a. So in this case, how much is f of minus 2? And how much is f of 1? What do you think? So f of minus 2, it will be minus 2 squared, which is 4. And f of 1, it will be 1 squared, which is 1. So therefore, the net change is going to be f of b minus f of a. So remember, this is a, this is b. If you switch the values, you still get the same answer, so it doesn't really matter. You just have to be careful. So in this case, f of 1 is what? 1. And how much is f of minus 2? 4. And how much is 1 minus 4? Minus 3. That's it. So that's the net change, which means it's going down. So, all right, what about you have 3 and minus 3? Same thing. How much is f of minus 3? It will be minus 3 squared, which is 9. And how much is f of 3? It's also 3 squared, which is also 9. So therefore, what do you think will be the net change? Remember, this is A, this is B. So this will be 9 minus 9, which is equals to what? 0. Which means nothing changed, that's all. It's perfectly fine. By the way, in terms of the slope, just to see if you remember this from your past lives, when it comes to the slope, remember, if the line goes up, it's positive slope. If the line goes down, it's negative slope. So this was positive, negative. And if it is flat, it was 0 or no slope. And if it went up like this was undefined or it doesn't exist. Those are the only 4 things that can happen with the slope. Okay, so here, now the question is asking you to find the whole thing, the slope. It says find the average rate of change. Okay? So therefore here, whatever you decide to do, and by that I mean this, if you say f of 1 minus f of minus 2, then on the bottom you have to have also 1 minus minus 2. Okay? And you do f of 2 minus f of 1, and you have to do minus 2 minus 1. So we did the top already. F of 1 was equals to 1, and f of 2 was 4. And then this is 1 plus 2. So notice that this will give you minus 3 over 3, which is negative 1. Okay? And then you switch it around, you'll still get negative 1. So that means the slope is going down. Okay? So then if we're going to graph those 2 points, the first point, so remember from here, the first point is minus 2, 4. And from here, the point is 1, 1. Those are the points. So if we graph those points in the line, in the equation, the first one is minus 2, 4, which is right here. And the other one is 1, 1, which is right here. And you can see how you do a line that this is going down. So that's why the slope is negative 3. Okay, oh, this should be F2 here only, like this. Okay, so you can see graphically that how it's going down. Now this one, remember what was the points here? Minus 3, 9, and what was the point for this one? 3, 9, right? So if we graph those now, notice that the 3 is right here, so this is 9, and this is also 9 somewhere here. So if you do a line through this one, notice how the line is flat, and that's why the slope is 0. So you plug it into the equation, the slope is going to be now f of 3 minus f of minus 3. On the bottom, this is 3 minus minus 3. So on the top, this will give you 0, because we did that already. Remember, this was 9 minus 9. And on the bottom is 6. 6 divided by anything is 0. Remember, anything divided by 0 is undefined, but it's okay for 0 to be on the top. And you can see here graphically the slope being 0 for the black line, and the slope being negative 1 for the red line right here. Okay, pretty straightforward. All right, any complaints, concerns on this? In the last question, is asking you to find the average speed. By the way, there is a connection between slope and physics, because most of you, depend whether you're a STEM major or not, you're gonna have to take physics, and you're gonna hear this all the time. So physics, in the physics notation or terminology, a slope and velocity are the same thing. And actually the acceleration is the slope or the slope, but we'll get to that later. So here it's asking you to find the average speed, which is asking you just to find the slope. So this is just telling you to find how much is d of phi minus d of 1, which is the slope. And then this is phi minus 1, where the formula for d is this right here. Okay? So then for this, you may need a calculator, but d of 1, let's do the easy one first. This will be 16 times 1 squared. So this is just 16 times 1, which is 16. But d of phi, it will be 16 times phi squared. This is 16 times 25. And this is 400. You should check those numbers later. So therefore, you plug it into the slope, which, remember, this is the speed or velocity. Then this is going to be 400 minus 16 over 5 minus 1. So this is 384 over 4. And then you use a calculator, I believe this is 96. So the speed is 96 feet per per second. So we use this formula like 10 times right now. This is the slope, okay? So what I'm going to do right now, I'm going to, remember you can also call this what? You could call this f of b minus f of a over b minus a, right? We did that already. It's the same, literally the exact same thing. And there's really no difference. This is like a medium rare, and this is well done. So now we're gonna go to like the other extreme. What's the other extreme of well done? Well, uncooked technically. So here it is. So instead of calling this one x1 or a, we're gonna call this one just the letter a by itself, just a. Okay. And instead of calling this one b, we're gonna call it a plus something else, because technically that's what it means, right? If you start here, you need more to move to this place, okay? What is that more? Well, we're gonna call it a plus something else, which is gonna be h. So therefore, this is gonna be f of a plus h, and this one is gonna be f of a. Now, again, it's very important that you don't forget this, because then people think you're doing something different, okay? We just need to modify the formula to make things easier, what we're trying to do. But this is still y2, this is still y1, this is still x2, and it's still x1, okay? But look what happens now, you plug it into this formula. Look, you plug it into this formula, the formula for the slope is gonna be y2 minus y1 over x2 minus x1. What happens on the bottom? Well, there is one thing that cancels on the bottom. What is it? The a's, and you end up with h. Okay, so now this looks very fancy. It looks like, oh, this is pretty complicated, but notice that this is nothing more than the value for the slope, or the formula for the slope. And since we change it and it looks different, it hasn't changed in the sense that it's still the slope, but now we're gonna call this formula the difference quotient, okay? This is gonna be the name. We're gonna call this difference quotient, which is the slope. And to make it more fancy, we're gonna use a new notation, which I'm gonna call it delta. Okay, so that's the same, for people that are in fraternities, they call delta, gamma, whatever. So delta is just the letter D, okay? But delta, mathematically speaking, means change. So like how things are changing. The slope tells you how things are changing. So that's why the difference quotient, I just call it delta, that's it. Which is also my dog's name, by the way, delta, okay? So let's go with the easiest example there is, which is a linear equation. And this is the function, okay? So what you had to do is calculate this. Technically, you had to find y2, y1, and then just plug it into the formula. Because the bottom, the x2 minus x1 is always going to be just h, okay? So this is what I mean, look. If this is the function, how much is how much will be f of a? It's going to be 3a plus 5, just like we did at the beginning of the class. And what about f of a plus h? Well, this is going to be 3a plus h plus 5. Now you can simplify this more, so this will be 3a plus 3h plus 5. Okay, so far so good. And then remember, delta is going to be f of a plus h minus f of a over h. And let me color code this to make things easier. So here it is, look. F of a plus h is going to give you all of this, and f of a is going to give you this. So just plug it into the formula. So this will be 3a plus 3h plus 5 minus 3a plus 5 over h. Let me put the colors again, look. This is this part, and this is this part. Okay? So now, what can you cancel there? The 3a cancels the 3a. And what else? The 5, right? That's good. So what is the only thing that is left? The 3h. And on the bottom you have the h. So then this cancel, and the answer is 3. Now, I told you this is the most basic example, and there should be no surprise at all that the answer is 3. Actually, you didn't get 3, you knew right away this is wrong for this reason. Like, recall, we did this the first day of class, that you have y equals to mx plus b, right? And if you have that, this is automatically the slope, the number in front, right? So that's the slope. So if you have, in this case, you have y equals to 3x plus 5, well, therefore the slope is 3. So you better get 3 because this formula is supposed to give you the slope, okay? Now, this is gonna apply to other formulas, but this is a reason to start with a basic problem so you can check, okay, the answer should be 3, so is that okay? So do the same thing, figure out what is f of a, what is f of a plus h, and then plug it into the formula. Remember, the formula was this. Okay, so just try this for 2 minutes. Okay, let's check on this. So f of a is just going to be what? A squared. So it should be simple, right? But this one is going to be a plus h squared. And remember that this is not a squared plus h squared. So you have to do FOIL for this. And you have to distribute. And once you distribute, and you should check this. This is a squared plus 2ah plus h squared. Okay, you should check that. Okay, and let me actually get rid of this for now. I'll do it a little bit. So then if you plug it into the formula, so from here you're gonna have delta is gonna be a squared plus 2ah plus h squared. So that's this part. So this gives you that minus a squared, which is the f of a, and then everything divided by h. Okay. So now clearly what we can cancel here is what a squared, and then you have 2ah plus h squared over h. Now from here you have several ways in which you can factor this, or simplify this. One of them is factoring, which may not be obvious for some people. So what I recommend you to do is the following, okay? So recall from middle school, elementary school, you have, let's say, 6 plus 4 over 2. What is the answer for this? Clearly the answer is 5, right? It's 10 over 2, the answer is 5. But notice that this is the same thing as 6 over 2 plus what? 4 over 2. And 6 over 2 is what? 3 plus 2 is 5. So it's the exact same thing. So if we use this, by that I mean break this into 2 pieces, it will make it easier for you to see what's going on. You don't have to, but it will make your life a lot easier. So notice this is equals to 2a, because the h will cancel, plus h. And that's it. Okay, so now this is the part where I want to tell you the connection with calculus and why technically this is the part that is hard, not calculus. So let me tell you what I mean by that. When you take calculus, the basic idea of calculus is called the derivative, okay? And the derivative is just a fancy name for the slope, the special form of the slope. Okay? So when you're taking calculus 1, they will ask you, use the following function, which is x squared, is the typical one where you start, to find the derivative, okay? So you literally have to do all the same steps I did right now. So all of this clearly is not calculus. Why? Because we're doing it here in the pre-calculus. So this is a pre-calculus problem. So you will have to do all of this, like all of this work. And the only calculus part is this. Once you have done all of this, what will happen to this part if h was 0? What will happen to this if h is 0? This will be gone, so the only answer will be what? 2a. So literally the calculus part is, okay, get rid of the h, and that's calculus now. So therefore, that's not the hard part. The hard part was to do all of this. And that's why people think calculus is hard. Calculus is not hard. If you forget the algebra, this is a calculus problem as long as you get rid of the h at the end. This is calculus. So 99% of the problem was algebra. The only calculus part is, okay, you're done with this, get rid of the h, what do you have left? 2a, well, that's the answer. That's it. But there's no way you can get there without doing all the algebra. So that's what I mean by calculus is very easy as long as you understand the pre-calculus part. Last problem we're gonna do, we technically did this last time. We didn't call it difference quotient, but we did this already. You'll see in 1 second. Look, let's say f of x is this. Also, look, so note, whenever the function involves a fraction, which it does in this case, it's a lot more useful to write a formula like this. I showed you this last time when I said that, 5/4 is the same thing as 1/4 times 5. So we're choosing to write it this way. You should only do that when you have a fraction, because it's going to make your life a lot easier, okay? You don't have to, but it will make life easier because you don't have to have a fraction over a fraction. You will only have to do it with one fraction at a time. So, and this is what I mean. So for example, here, f of a, it will be 1/a. And f of a plus h, it will be 1/a plus h. And I don't know if it was last class or 2 classes ago, but we did this for sure in the class. Notice that you have f of a plus h minus f of a. This is what you have. You need to figure out what the LCD was. We did that last time, and it was a times a plus h. Since you're adding fractions, you need to multiply by whatever is missing to get to the LCD. This one is missing the a plus h. This one is missing the a. And then remember from here, this one you have a minus a plus h divided by a times a plus h. Here the a's cancel, and you end up with minus h over a plus h. Okay? Again, this is not new. You check your notes. We have done this in a different context, but it's the exact same question. And now notice that this part, okay, this part in green is exactly this, or this answer right here, okay? So the only thing that is missing is what the 1/h. So therefore, delta is going to be 1/h times the difference, which is this, or the net change technically. And notice that the h cancel, so the answer will be minus 1/a plus h. And that's it, which is exactly the same answer we got if you check your notes from last week.